Saturn V rocket. Also using the Apollo 11. I know, but the one used in 1969 is way more different than the one we're gonna use right now. Because that one only took them to the moon 17,400 miles per hour. This one can take us 160 light years per hour maximum. This one can take us beyond what you can imagine. This can take us wherever we want in the universe. That's why our company's called Universal Expeditions. Are you ready? Let's show UE companies what we're made of. Let's review where we're going. Our first destination is Jupiter, which is about 590 million kilometers away. Our second destination is the Kuiper Belt, which is about 15 billion kilometers away. And then we reach our next stop, the Kepler 186f, the most questioned planet, which is 490 light years away. That's an interesting one. I know. Our next destination is the Orion Nebula, which is about 1,300 light years away. And then finally, we reach to our last destination, the nearest black hole in our solar system, Sagittarius A, which is 1,600 light years away. Oh, I can't wait for this. This is going to be one exciting journey. Do you remember that the effects of reacting between bodies is that the fluids can redistribute to the upper body parts, causing facial puffiness, nasal congestion, and headaches? Oh yeah, I remember. But it does make our legs more slimmer though. You know that, right? You have a point there. But don't forget that because there's no gravity in space, this can cause a loss of sense of direction, space motion sickness, and disorientation. Oh yeah, that's true. And there's a lot of dangers going space traveling too. Like we can have higher risk of cancer, kidney stones, and we can get like irregular heartbeats, which is really dangerous. But you know, curiosity kills the cat. You ready? Okay. Okay, let's prepare the engine. Okay. Going at 600 meters per second. Okay, increasing at 1 kilometer, officially starting at 81,666.7 kilometers per second. Let's go, Lena. First stop, Jupiter. Here we go.
5, 4, 3, 2, engine start, 1.
Blast off! Okay, I'm currently passing the asteroid belt. We have 359,034,889 kilometers more till we get to Jupiter. It's gonna start getting cold after we pass the asteroid belt. Let's turn the heaters on. Cutting off engine, turning on autopilot. Time right now is 11 o'clock. Estimate arrival, 1 hour. That's just to get in for a ride.
1 hour later.
This is Jupiter. So this is the biggest planet in our solar system. Yeah. Did you know that the dark stripes on Jupiter are called belts? And that the light ones are called zones? Really? Yeah. And the zones are made out of hydrogen and helium. Oh, and Jupiter also has the greatest gravity. Oh yeah. You know how Jupiter has a really strong gravity and it's like right beside the asteroid belt? The comets that would have been struck to Earth, Jupiter would take it. So let's be glad that Jupiter's here, because if Jupiter wasn't there, the comets would have been struck to Earth and then we would have been dead. And oh yeah, look at that, it's the Great Red Spot. Oh yeah, apparently the Great Red Spot has 3 times the diameter of Earth. Oh yeah, and the Great Red Spot is like a rotating high pressure system, or in other words a weather, and it's been there for over 300 years. Wow. Okay, so you want to move on to our next stop? Kuiper Belt? Sure. The time is 12 p.m. The expected arrival is at 2, so it's going to be a 2-hour long travel. Okay, ready? Blasting off at 3, 2, 1.
2 hours later.
Whoa, so finally we're here at the Kuiper Belt. Why is there so many rocks here?
So many rocks, oh my gosh.
Yeah, those are called the Kuiper Belt objects, and they're composed almost entirely of icy chunks.
Whoa.
And the Kuiper Belt also surrounds our entire solar system.
Oh yeah, and they said since the Kuiper Belt is so far, it can support substances that's very explosive. And it's been here since the early formation of our solar system, so scientists are so curious about the remnants of the Kuiper Belt.
It's really amazing.
So, you want to go to our next destination now?
Yep, Kepler 86F, here we go. Converting to light years.
Okay, putting on sensitive mode so we won't get into any accidents with the Kuiper Belt objects.
Increasing at 210 light years per hour.
And blasting off at 3, 2, 1.
2 hours later.
Whoa, this is the Kepler 186F. This looks exactly like Earth.
Actually, it's 10% larger than Earth. And did you know that the Kepler 186F orbits 3 times closer to its sun, which is an M dwarf?
But isn't it going to be hotter?
No, because the M dwarf is cooler actually.
Oh yeah, and M dwarf lasts longer too, so scientists think that this planet would be suitable for us. And since it's also in the outer of the habitable zone. But the atmosphere is thicker since the planet is a little bit larger, so and the water would be frozen, so I don't think it would be more habitable. And well, yeah, and it's really far too. Oh, let's just look at the view. So you want to move on to our next stop?
The Orion Nebula?
Yeah?
It's gonna be a beautiful sight.
I know. Okay, setting it at 405 light years per hour. Expected arrival is 2 hours to get there. Ready?
Blast off in...
At 3, 2, 1!
2 hours later.
This is so magnificent. I can't believe this would exist in real life. Like,
Orion Nebula is probably one of the brightest and most noticeable constellations in the night sky. Its clouds are made of gas and dust, and because of that, its colors are greenish tint and red and blue violet.
and the Orion Nebula is also known as the M42, where stars are born. It gives birth to perhaps 1,000 of stars. And the stars are abnormally peculiar as it moves really fast when it doesn't even have a high mass.
You want to know what it's like to go through Orion Nebula?
Sure, let's go. It's located at the center of our Milky Way galaxy, so are you prepared to whatever the consequences may be?
I'm ready.
Okay then, ready to blast off? Okay. At 3, 2, 1. What?
2 hours later.
Okay, docking it at 1 light year away from the black hole. As you know, you don't want to get sucked into that. You know, it's 4 million times larger than our own sun.
Wow. And at a distance of 26,000 light years, this yields a diameter of 44 million kilometers.
I picked this black hole because it's a poor eater, because it's used the fuel. They use high velocity winds from nearby concentrated young stars, and they're like really big. But since they're really far, like really far, it's hard for the black hole to capture and swallow it. So that's why it's a poor eater. And it's previously assumed that it takes in 1% of that wind, but actually it takes in 1% of that 1%.
Oh,
Yeah.
This is your last stop.
Well, this was one amazing experience. I guess it's time for us to go back to our home sweet home.
Yeah. It took us 10 hours to get here.
Really? So it's gonna take us 10 hours to get back.
Yeah. So all in all, we spent 20 hours in space. But on Earth, it's gonna be 2 years that passed.
So basically 10 hours is actually a year.
Yeah.
Well, at least we get to experience this once in a lifetime chance. Are you ready, Specialist Agent 2?
I'm ready, Specialist Agent 1.
Okay, well, we have 1,600 light years till we get back to Earth, and we're gonna increase the speed to 320 light years per hour. Ready?
Blast off in 3,
2, 1.